In the realm of science, enormous privileged insights into the topic of existence prior to the significant impact have intertwined conversations and piqued interest for a very long time. This Goliath request tests more than just our methods. It could separate the universe from itself. It challenges the actual requirements of human understanding. Standing on the brink of death, studying the enormous shadowing, and taking into consideration what was there before our universe was imagined, the Big Bang, which established the beginning of history, the universe, and what we are, regardless, we know that there was a moment. Sooner rather than later, this may eventually have been a state of calm before the explosive nothingness. Getting organized and assuming that this is either legitimate or that there was something significantly more traumatic that existed long before time, we skip ahead to the science of this request. This takes us to the place where the beginning of the universe was thought of, putting our mindfulness to the test. Physicist Brian Cox, well known for his work on the universe's miracles, suggests that a shocking event might have moved us before the Big Bang, forcing us to reconsider how we perceive reality. In this assessment of the world and existence, we will examine the science, speculative behavior, and amazing insider secrets that could uncover what was there before. Before all that, we'll investigate thoughts like God's improvement, quantum mechanics, dark energy, and the multiverse. The responses we discover may restrict us, but they might also open up new comprehension of our situation within the grand design of the universe. To plunge deeply into a world that goes beyond science and imagination, where the shadows continue to circle, we must examine why these hypotheses pose a threat to everything we anticipated and knew. To appreciate what could already exist, we must first examine what the Big Bang was. Scientists describe the occurrence as a rapid expansion where the universe's temperature skyrocketed. This initiated the process by which all matter and energy emerged. When we look at the universe, we see no boundaries, only the hot substance spreading from a point of origin. But why did this occur? Was there a time when it wasn't so hot? Cosmic theory demonstrates that inflation occurred before the Big Bang. It was a state of the universe that was cold, unoccupied, and fundamentally similar to an enormous vacuum. However, this vacuum was not entirely empty. It held an enormous amount of energy that controlled the expansion of space itself. This event, called inflation, occurred so quickly that its cause remains unresolved. Everything continued in a single piece of a continuous area, expanding at extraordinary rates until the expansion slowed down, transforming energy into matter and the forces we observe today. Take into account the Big Bang, but what was the nature of this energy, and where did it come from? Why did it stop? Scientists believe that this unending growth resulted in each patch of the universe undergoing its own Big Bang, akin to a material expanding continuously, with each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that there are potentially unimaginable Big Bangs, resulting in innumerable universes like ours. This unpredictable reality tests our understanding and raises profound questions. Alternatively, what if before the Big Bang, there was nothing? Theoretically, this concept challenges our current comprehension. Even if all energy, particles, and cosmic radiation were destroyed, the universe would not be truly empty. Dark matter, dark energy, and quantum fields suggest that even at its most vacant state, the universe is still something. If we removed these forces, would the universe disappear into true void space? Or would novel forms of energy still emerge? Scientists are baffled by this possibility because it suggests that absolute absence may be beyond comprehension. Space itself has rules, properties, and constants preventing it from being completely devoid of content. Imagine constructing a region with no particles or radiation, only negative energy and quantum fields. Even then, these fields would remain, indicating that nothingness has inherent characteristics. A concept known as zero-point energy exists, symbolizing the lowest conceivable energy state. Particles continue to emerge and dissipate, creating a subtle resonance of improvement within what should be empty space. This challenges our assumptions of a genuine void, suggesting that before the Big Bang, something may have existed, something that researchers are only beginning to understand. One of the most astounding theories in modern cosmology is the possibility of unstoppable progress. If inflation could endure indefinitely, it might have created our universe and many others. Brian Cox describes a massive multiverse where universes are continuously created in an unimaginable way. Consider each Big Bang as a spark, igniting an additional universe while inflation occurs in various regions, generating countless new universes. This cycle could theoretically continue forever. The concept of enormous universes interacting results in a fascinating possibility, a fractal-like reality where each new universe spawns its own. Every universe, created at its own Big Bang, remains independent, unaffected by others. This hypothesis is both thrilling and unsettling, suggesting a seemingly endless multiverse without a distinct beginning or end. Finally, picture our universe as merely a tiny part of an infinite, ever-expanding design. What if that is the true nature of reality? Perhaps there is neither a past nor a future, but rather an eternal cycle of universe formation. When we take into consideration the theory of the quantum field, we see that the universe is more than just a mixture of space-traveling matter. It is a complex energy network, fields interacting across the universe to bring everything into existence. Similar to intangible seas, these fields form waves, creating matter even at their lowest energy levels. In the vacuum state, they still function, with particles forming and disappearing, momentarily gaining energy before returning it. This feature gives rise to virtual particles, entities that appear and vanish instantly, leaving behind a trace of their presence. The existence of virtual particles challenges the idea of true emptiness. If everything in the universe were stripped away, would nothing remain? According to quantum field theory, even in a vacuum, energy fields remain active, generating transient particles. This suggests that the universe does not adhere to our conventional idea of nothingness. The presence of dark energy further complicates our understanding. As the mysterious force driving the accelerated expansion of the universe, dark energy may have existed before the Big Bang. If so, it could have regulated inflation, causing rapid expansion. This raises a compelling question: was the universe ever truly empty? Or did dark energy persist, shaping the early cosmos? Dark energy could be the silent force behind inflation, or even the true beginning of our universe. If we consider this possibility, we face the notion that dark energy is not just influencing our universe but could be a key to accessing others. Another theory, cyclic cosmology, offers an alternative perspective. It suggests that the universe undergoes massive cycles of birth, death, and rebirth. The Big Bang, in this model, event, but perhaps a component of an eternal cycle in which distinct universes develop and then recover in a subsequent cycle. According to theory, our universe could have been reconstructed from the ashes of a previous universe. The procedure of cyclic compression and expansion would imply that there was never an actual beginning but rather an eternal series of emerging universes that continually renew themselves. Cyclic cosmology raises significant questions. There is no other time like the present, as it suggests that time could repeat itself instead of proceeding linearly. If this theory is true, it could imply that what previously existed before the Big Bang was just another shattered form of the universe, bearing our current existence. This theory provides scientists with an extensive response to the question of extreme origins, asserting that there is no clear beginning to the universe. It has always existed in some way beyond our perceptions of existence and time. Gravitational waves are another intriguing concept that may shed light on the world prior to the Big Bang. Discovered in 2015, these waves are ripples in spacetime caused by extremely massive objects like black holes or colliding neutron stars. These waves can transport information over long distances regarding the occurrences that produced them. Some physicists propose that gravitational waves emanating from the period before the Big Bang may offer insight into the universe's state prior to the onset of inflation. Gravitational waves from the beginning of the universe might provide clues that help determine whether the Big Bang was truly the beginning or if cosmic entities existed before it. These waves might be traces of events we do not yet know about, potentially influenced by circumstances beyond our usual understanding. If detected, they could reveal a larger structure beyond what we are accustomed to. These faint signals could provide knowledge that alters our worldview, much like how we discovered the beginning of the Big Bang. Scientists suggest they might display the lingering traces of an earlier universe or an incident that occurred before the Big Bang. The question of what existed in space prior to the Big Bang remains open. Theories pointing to quantum mechanics and cosmic inflation bring us closer to revealing the universe's mysteries. While we still lack a comprehensive response, our understanding of what existed before the Big Bang continues to expand with each new discovery. As we investigate these theories, we can consider how they fit together to illustrate the larger picture of existence. Until then, we are left with the mystery, pursuing science and venturing into the unknown. Exploring the mysteries of the past before the Big Bang makes it increasingly clear that our comprehension of the universe is constantly evolving. The relationship between space and time itself remains a key subject of exploration, as we encounter concepts that challenge our traditional understanding of existence. Some hypotheses suggest that time itself emerged from the Big Bang, making it impossible to identify previous events. This idea questions our fundamental perception of existence, implying that the concept of when might not even be meaningful in relation to what preceded the Big Bang. Recent advancements in quantum research have introduced new concepts regarding the nature of reality. The idea of a quantum vacuum, a state where there is no matter, yet energy fields fluctuate, suggests that quantum fluctuations may have played a crucial role in the universe's development. These fluctuations might have created the necessary conditions for the Big Bang to occur. The question remains, did the universe begin as a fluctuation in the quantum state, or was it caused by changes in another aspect of the cosmos before the Big Bang? This idea remains speculative, yet it aligns with cyclic cosmology, where the universe undergoes endless expansions and contractions. In this view, the universe would expand from a singularity, eventually collapse, and then expand again in a never-ending cycle. Some theorists suggest that each cycle produces different results based on the circumstances of the previous one. This idea challenges the notion of a single creation event, instead proposing that the universe is in constant renewal. The potential existence of multiple dimensions adds another layer of complexity to our understanding of what preceded the Big Bang. String theory, for instance, hints at the existence of additional dimensions beyond the familiar three of space and one of time. These dimensions could offer a completely new framework for comprehending the origins of the universe. In this model, the Big Bang might have been triggered by interactions within a higher dimensional space, where the collapse of a multidimensional structure led to our three-dimensional reality. If this theory is correct, it would not only provide insights into what existed before the Big Bang but also introduce new possibilities for understanding the fundamental workings of the universe. As we approach the limits of current scientific knowledge, it becomes evident that there is still much to discover. Scientists continue to study the Big Bang, pushing the boundaries of what is possible through new discoveries and technological advancements. Perhaps one day, we will unravel the universe's ultimate origins, gaining a deeper understanding of the forces that shaped our existence. Until then, these inquiries will continue to challenge us, inspire awe, and drive us to explore beyond the familiar, seeking answers to the innumerable possibilities that exist. As we advance in our understanding of the cosmos, new theories continue to emerge, challenging our perceptions of time, space, and reality itself. One such theory suggests that the Big Bang may not have been a singular event but rather a transition between different states of existence. In this view, our universe could be just one of many in an ever-expanding multiverse, where each universe emerges, evolves, and potentially collapses, only for another to take its place. Quantum mechanics plays a crucial role in these discussions. The uncertainty principle, which governs the behavior of subatomic particles, suggests that the fabric of reality itself is not as fixed as it seems. If space and time are subject to quantum fluctuations, then the concept of a definitive beginning to the universe becomes more ambiguous. Some scientists propose that the universe may have emerged from a quantum vacuum, where energy fluctuations created the necessary conditions for the Big Bang. Additionally, the holographic principle, a concept rooted in string theory, suggests that the universe might be a projection of information encoded on a distant boundary. If this idea holds true, it could imply that what we perceive as physical reality is fundamentally a manifestation of underlying mathematical structures. This perspective challenges traditional notions of spacetime and raises profound questions about the nature of existence itself. As researchers continue to push the boundaries of cosmology, they explore the possibility of extra dimensions, parallel universes, and even the idea that our reality may be part of a grand simulation. While these ideas remain speculative, they offer intriguing possibilities that could reshape our understanding of the cosmos. Ultimately, the quest to understand what came before the Big Bang is more than a scientific endeavor, it is a philosophical one. It forces us to confront the limitations of human knowledge and to consider the possibility that some aspects of reality may always remain beyond our reach. Yet, as history has shown, the pursuit of knowledge often leads to unexpected discoveries that challenge and redefine our understanding of the universe. As we continue to probe deeper into the mysteries of existence, we may find that the answers lie not in a singular moment of creation but in an infinite web of cosmic interactions that stretch beyond time itself. Until then, the search continues, driven by curiosity, imagination, and an unyielding desire to explore the unknown.